Today's lesson, we're going to be finding the hypotenuse of a 3D figure. And so we're actually going to be doing the Pythagorean theorem twice. So I want you to start with this first problem on top, where the flowers. And so they gave us that across the base, that is the size 8 centimeters. Up the side of that cylinder is 15, so I know those make a right angle. And you need to find the hypotenuse. And so you can do this on your own. We always start with the formula. A squared plus B squared equals C squared. Now take a minute to fill in what you know, solve, and then come back and check your work. So I went ahead and did the problem. I said A was the side of 8 at the bottom. I said B was 15, the side. And when I solved, I got C is 17. So my answer to C is 17 centimeters. Now, the next one is find the distance between the 2 points. The nice thing is we can connect these 2 points on a diagonal. Okay, well, in order to find that diagonal line, we have to count boxes to figure out what's the leg, what's my other leg, so I can find that hypotenuse. So you want to make a triangle out of those 2 points. And I see the bottom is 3 and the side is 4. So I'm going to have 3 squared plus 4 squared equals C squared. Pause the video, finish this problem on your own, come back to double check your work. When I solved, I got 5. So C is 5, and because it's on a grid, my label this time is simply units. So 5 units. Now, to find the diagonal going through a prism, you may need to use the Pythagorean theorem, and we actually are going to use the Pythagorean theorem twice. So the first thing we have to do for each problem is we need to look at the base of our figure. So we're going to look at our rectangular prism's base, and we are going to find the hypotenuse of that base, because that hypotenuse is going to give us a leg for the diagonal of the box. So we're trying to find a diagonal going through a box. And in order to do that, we need to know the hypotenuse of the base, and that hypotenuse is then used a second time as a leg. And so it gets a little confusing, but the more we practice, the more it makes sense. So we start finding the base. So you find first, find the hypotenuse of the base. And then we're going to leave that in the square root form, because then we're going to take number 2 and we're going to use that answer as a leg for round 2. So we're going to do 2 rounds with the Pythagorean theorem, and our first answer then turns into a leg. So it starts as a hypotenuse and it turns into a leg. And we can talk about this in 3-dimensional figures, and you can ask Miss Morose, but you're finding the diagonal through a box. It's a little hard to visualize. The easiest way to figure this out is with an example. So let's look at the base of this box. So we have a base right here. And what I need to do is I need to find the hypotenuse, because I'm given this rectangle. So I have a triangle in here. I know boxes have square corners, even though it doesn't look square. And I need to find the hypotenuse. So my leg here is 6, and my other leg is the other side of that box, which is 4. So the first round of the Pythagorean theorem, I'm finding the hypotenuse of that bottom of my box. So I have 6 squared plus 4 squared equals C squared. So 36 plus 16, 52 equals C squared, square root, square root. This is where we just leave it in a square root. So we're going to say C equals the square root of 52. We don't even need to bother with a calculator yet. So the hypotenuse of the box that I colored orange is the square root of 52. Now what we need to do is we need to find another hypotenuse for the entire box going corner to corner. So if I outline this, my one leg is orange, my other leg is green, and those two things make a right angle. And then I need to find that blue hypotenuse. So part 2, Pythagorean theorem again. My one leg is orange. That's this answer here, square root of 52. So I'm going to say the square root of 52 squared. Not even going to bother with the decimal, just leave it the way it is. Plus my green side, which is 10 squared, equals the hypotenuse, the blue line I'm trying to find. How diagonal is that box? And the cool thing here, when I have the square root being squared, they're opposite operations, so they cancel. The square cancels the square root, and I'm left with just the number inside. The square root of 52 squared is just 52. Then, plus 10 squared is 100, equals c squared. So I have 152 is c squared, and now I'm going to square root that value. Now I finally pull out my calculator. I haven't needed it since then, but now I'm going to get my calculator out and find the square root of 152. And when I put that in my calculator, I end up with 12.3 when I round to one decimal. And then I'm going to label, I don't see any labels on my box, but I'm going to say it's centimeters. I shouldn't see any decimals in your work until your final answer. When we do problems with this, where we're finding that diagonal piece, we always have two answers. We have the first part's answer that's left in that square root form that we're going to use in the second part. And then I finally have my finished final answer, that second answer in decimal form at the very end. I haven't used the calculator to convert a square root until that point though. So we shouldn't have any decimals until the very last problem. Now, because this is kind of tricky, we're going to do one problem off of the homework together as well. So look at the first problem on the homework, and the directions say we need to find the diagonal of A to G. So that's diagonal across the entire box. So just like on the last problem, start with the base. We need to find the hypotenuse of the base going from A across our box to C. So this is the hypotenuse we need to find, is that orange line I just drew. So the first thing is find my orange hypotenuse. So if we start with the Pythagorean theorem, my legs are 9 and 3. So I'm going to have 9 squared plus 3 squared equals c squared. 9 squared is 81. 3 squared is 9. When I add them together, I get 90 equals c squared. So square root. C equals, the square root of 90. I don't need a calculator yet. I'm going to leave it just like that, square root of 90. I know that's unusual, but we're going to use that square root in number 2. Now I'm going to highlight what my triangle is. My triangle has an orange base up the side of my box, and then that purple hypotenuse. So I'm making my triangle pink. And if we look, there's my right angle. So let's look at my sides. A squared plus b squared equals c squared. My one leg is that orange leg I had. Square root of 90 squared. B is the side, so that's 6 equals c squared. Remember what we said, square root and squareds cancel. So I'm left with just the number inside. So I'm left with just 90. 6 squared is 36. And I'm going to add them together to get 126 equals c squared. Now when I take that square root, I now put this number in my calculator. So let's figure it out. When I do that, I get 11.2 equals c. So the line A to G is 11.2 meters. And there is my answer. My first answer is left in a square root. My second answer, I use the decimal form.